Let's review the rules when we are having a science discussion. What are some of our agreements?
We know when to talk when nobody else is talking.
What about if you notice that somebody isn't sharing?
You can work together to try to share and solve your problem.
You bring them into the party.
You bring them into the science party, into the science discussion, exactly. The one thing that we worked on last week was where we had our Legos. What do those Legos represent?
Legos represent building on each other's idea.
Okay, so remember today as we start getting into our science discussion here that we're building on each other's ideas. So what we learned about and what we've talked about the past couple of days is what might increase the rate of erosion. This was a model for a river, and when we increased the angle a little bit, can somebody explain what the water flow was like?
The water kept going faster, like when it was 10 degrees, it took 4 seconds, but when it was 55 degrees, it took 1 second.
The erosion forced it to go faster.
That's a great place to start our claim. We think that increasing the angle of the stream table will increase the rate of erosion.
It left us with a lot of canyons plus the delta, which made it pretty interesting.
Let's see if we can see Christian's group up on the screen to see the rate of erosion with theirs. So we're looking for that increased rate of erosion. I mean, look at that. What is that even in 20 seconds? In 12 seconds it went through. Okay. How do we think this connects to our phenomenon and the mysterious landscape? My name's Jennifer Witten, and I teach 4th grade at Beaver Acres Elementary. And what you saw today was the end of about a 2 or 3 week unit where our class has been working on a phenomenon. Started the unit showing them some pictures of a landscape in eastern Washington. It didn't explain how the land was formed. So what the students did after watching that was they created their own model of what their thinking was about how this landscape was formed.
This project is about discovering what created those weird holes. When we did our experiment, maybe, do you remember when the water started falling? It made a hole on the sand? Maybe it made a huge hole on the sand and made those black holes.
Oh my god! It's creating the delta.
That's okay.
Oh, there's another one. I think there was a little hole and the water started coming in, and then it created more cracks because the water was coming in. Yeah. And it created more holes and more, and it created bigger, which created a canyon, and that relates to our stream table.
Those holes are from those rocks, and then the water moved those rocks to a different area, and then made multiple.
What do you think, Kashmir?
I go with Nicholas's idea.
Experiment 1, which most represents the landform.
I think it would be experiment number 3, because number 3 added more water, and it was like more efficient. Maybe there was more water than less water. We pulled up the old video to see which one was more efficient, and I think it was number 3 because there was like a little delta and the whole thing almost collapsed.
This process started with watching a video of the landscape in eastern Oregon, and Mrs. Witten asked us what caused it, and what we thought was the waterfall. And then we did a few experiments to figure out what caused the landscape, and now we are making a model of what we think happened.
I'm just gonna give groups about 1 more minute, and then we're gonna have a board meeting. We're gonna meet and present our ideas, okay?
We used to think that a drought dried the ocean up and a volcano caused the soot and ash. Now we think that a flood caused the canyon and carried the boulders to random places, and the water pressure caused the holes. And the stream table experiment supports our idea because when the water hit the land, it made a canyon and caused erosion.
Any questions for this group?
Is there still a volcano in this or no?
No.
How did the bits of rocks make the ash?
The water chipped away bits of rock.
Today what you saw was this board meeting where they revised their thinking. They had to include all the ideas from the activities that we did, and tomorrow we will watch the entire video and they will be able to see if what their theory validates what really did scar this landscape. This is part of some practices that have come with the next generation science standards. What I've been most excited about with these standards is the role that language plays in science, and I find that these standards really align well with language development. As you saw today, the students have a lot of time to share their thinking, their reasoning, they're using evidence to support their thinking, and then they're explaining their ideas and changing their thinking. All of those are science practices, but they're improving their language through learning new content. And as you can see, it's really engaging. Students are 100% engaged, and they're really doing some incredible work in here, I think.